Let's look at a slightly more difficult example. Consider the uranium conversion and pellet fabrication step. In this step, the material balance area receives uranium powder, transports uranium powder scrap to waste, and transports uranium pellets for fabrication to fuel assembly and pellet storage. This material balance area is considered a bulk accounting area, as discussed earlier. The uranium powder received by the material balance area is weighed to measure the uranium mass. The uranium powder shipped to scrap is also weighed to measure the uranium mass. The uranium pellets are counted, and an average uranium mass per pellet is used to determine total uranium mass shipped out of the material balance area. For a given material balance period, the state system for accountancy and control reports the following uranium masses and enrichments entering and leaving the material balance area. Again, we assume that the material balance area is cleaned out at the end of each material balance period, resulting in PB and PE equaling 0. In order to calculate the inventory increase, X, we need to calculate the uranium-235 mass in the material received by the material balance area. This is done by multiplying the total uranium mass by the uranium enrichment. If done correctly, you should get 1,496.2 kilograms of uranium-235 was received by the material balance area. The inventory decrease consists of shipments to waste and shipments out as pellets. The inventory decrease due to shipments out as pellets is the number of pellets multiplied by the uranium mass per pellet multiplied by the uranium-235 enrichment. This calculation reveals that 1,458.1 kilograms of uranium-235 were shipped out of the material balance area as pellets. The inventory decrease due to shipments out as scrap is the uranium mass multiplied by the enrichment. This calculation reveals 16.5 kilograms of uranium-235 were shipped out of the material balance area as scrap. By combining these values using the MUF equation, a total of 21,025 grams of uranium-235 are unaccounted for. This material might have been diverted, but to know that, we need to check and see if this missing material is embedded in the uncertainties in the measurement. Using techniques discussed in the Introduction to Statistics course, we can propagate the uncertainties in the MUF calculations to determine if a material diversion from the facility has occurred. In front of you, you can see the uranium-235 mass and uncertainty for the received material, shipped pellets, and shipped waste, respectively. Combining all of these values yields an uncertainty on the MUF value of 26,624 grams of uranium-235. Thus, our MUF value is less than 3 times the standard deviation of the uncertainty. Although this is good, the uncertainty in the MUF is large, and some changes to the measurement systems and process flows are needed to get 3 times the uncertainty below one significant quantity.